Hi, I'm Sher Mehta. I work for an economic research firm. I've been in the field of time series econometrics from 2003 to date. I worked in London and I'm currently based in India. Today I'm going to show you how to actually test whether a time series data is stationary or not. And for this purpose, I'm using the Eviews econometric software. Now, if you were to view this screen out here, I've taken the example of US real GDP, and the range is between 1983 quarter 1 to 2023 quarter 1. So this is quarterly data and it's time series data. So this is this is the data. Now I'm going to show you a step by step approach by which you can test the US real GDP time series data and see whether it is stationary or not. So as a first step, you have the menu here. You go to quick, you generate series. What we are doing here is that we are converting the US real GDP into logs. So out here I'm going to type in ln US real GDP is equal to log US real GDP. So as a first step, if you get such economic data, it is advisable to first transform it into a log form. So what I've done is I have transformed this data into logs, which out here you can view. This is exactly it. I have transformed it into the log form. Now after which, if you go to view, now as a first step, what we are going to do is I'm going to show you two informal ways by which to test whether this data is stationary or not. The first one is the the first one is the charting of the data. So from view, I'm going to press on the tab graph. Now out here you already have the line and symbol option here. So after which I'm just going to click on OK. And here we have the series here. Now if you can view out here, just by observation, this seems to be a data that is non-stationary. The mean is changing over time and it doesn't revert to a long-term mean. And the other thing is that if you were to view the data, there is the presence of a trend. Now I'm not going to go into how volatile the data here is or whether it has outliers or structural breaks. That I'll keep to some other video. I'm just trying to show you how to test using both informal and formal methods. So from here, after having viewed this, now the second informal way of seeing whether this data is stationary or not is the correlogram. So from view, I am again going to correlogram here, and this is in the level form. The lag length is automatically selected here. I mean, it's automatically there. So I just need to press on the OK tab here. Now if you see the ACF function here, there is autocorrelation at every lag. A faster way to see this chart is if you look at the probability value here, all these are less than 0.05. So when all these are less than 0.05, this is indicative of a non stationary time series. So these are the two informal ways that indicate whether a data is stationary or not. But it's very important to complement this with certain formal tests. So I'm going to show you three formal tests and exactly how to do them in Eviews. So now I'm going to go to view. Then you select the option unit root test. Thereafter, go and select the standard unit root test. Forget about the breakpoint unit root test for now. This is just that we are actually focusing only on whether the data is stationary or not. So from the unit root test, we go on and we select this tab, standard unit root test, and then we click on it. That's it. Now, after which, these are the various tests that they are given: augmented Dickey-Fuller test, Dickey-Fuller, Philip-Perron. Now I'm going to choose the first test here. After which, we have to, among these three options, we choose the option of a level. And include in the test equation, we have intercept, trend, and none. Usually in such time series data, you have a trend and an intercept. Now out here, we have various options. You can choose the AIC, SIC, Hannequin. So out of these three criteria, I'm going to choose the Schwartz information criteria. You can choose AIC. That's also all right. You can choose Schwartz. You can choose this, but I'm choosing the Schwartz info criteria here. Yeah, that's it. And the maximum number of lags is automatically chosen by Eviews. So you don't have to do a thing. You just have to focus on choosing the option of augmented Dickey-Fuller test, following which choose the level option, trend and intercept, and the Schwartz. Then you have the maximum lags is already there, and then you just press on the tab OK. There you are. Now with this augmented Dickey-Fuller test here on the US real GDP, the null hypothesis is that US real GDP has a unit root. Now if you go down, we have the augmented Dickey-Fuller test statistic, which is minus 2.4. Now usually we choose the 5% level of significance. So out here you can see that minus 2.47 is less negative than minus 3.4. So we can conclude that this data has a unit root, which means that this data is non-stationary. You can also see this at the 1% level significance and at the 10% level significance. This is minus 4.0, and at the 10% level it's minus 3.14. So this minus 2.47 here is less negative than all these three numbers here. But usually, since we focus on the 5% level significance, you can see that that minus 2.47 is less negative than minus 3.43. So the series is non-stationary. Another way of looking at this is that if you were to view the probability value, you can just see here that 0.03 is greater than 0.05. And since the probability value here of 0.34 is greater than 0.05, you conclude that this data has a unit root, which means it is non-stationary. Now from here, the next step is that we go down, and here we look at the constant and the trend. Now if you were to view the probability value of both the constant and the trend, both are less than 0.05. For the constant, 0.01 is less than 0.05, and for the trend also, its 0.04 is less than 0.05. So we can conclude that we have chosen the right option, which uh, which is constant and trend. So so, so basically, to sum this up, that this test shows that the US real GDP series is non-stationary, and we have chosen the right option of constant and trend. So this is the first formal test. The next test, which I usually use and which to me is a much better test, especially when you have data which is volatile or which has, a structural breaks. It also takes into account serial correlation and other issues in the errors, but I won't go into that just now. But it's just that I'm going to show you this second test now. So again we go to the view tab, and after which I I'll go to a unit root test option, and again click on standard unit root test. And here I'm going to scroll down and choose the Philip Perron test. Now out here the test is in level. We have again chosen trend and intercept, and this part out here you don't have to do a thing. So you just choose Philip Perron, level, trend and intercept, and just click on OK. Now out here we have the Philip Perron unit root test, and the null hypothesis is that the US real GDP has a unit root. Now if we go down, the Philip Perron test statistic is minus 2.45, which is again more negative than which is again less negative than the 5% level of significance of minus 3.4. And also if you look at the 1% level and 10% level, minus 2.4 is less negative than all these three. So but since we usually use the 5% level significance, I'll focus on this number here, and this is less negative than this. So we can conclude that the US real GDP is a non-stationary, and the probability value here again of 0.35 is greater than 0.05. So we can again conclude that this test confirms that the US real GDP has a unit root, which means that this data is non-stationary. Again we go down and we look at the constant and the trend here, and in both these cases the probability value is less than 0.05 for constant and less than 0.04 for the trend. So in all, this is the Philip Perron unit root test. Now what I would say is, what I would actually recommend is that data is getting more and more volatile, economic data, because of the exogenous shocks to the world economy. And this in my estimation and my experience is going to increase. So in view of that, out of the ADF tests or the DF tests which I have not shown, those are the low power tests. It is preferable to use Philip Perron test, and due to the volatile nature of the data, whether it is any other abnormality, structural breaks, when you do unit root testing, it will be one must go into the breakpoint unit root test. Now this is something which is a separate topic, which I will show in a separate video. Just now we'll just go back to the standard unit root test again. So I'm going to click on the standard unit root test, and I'm going to now choose the third formal test, which is known as the KPSS test. This is the KPSS test, which means in this category, this is the fourth one, but this is the third test, the third formal test that I'm using here. Okay. So this is the option that I choose. Again, I've chosen the level option, then the trend and intercept. And here you don't have to do a thing, just leave it as it is, and then you just press on the tab OK. Now out here, the null hypothesis is the opposite of the first two tests that I had shown. Here the null hypothesis is that the US real GDP is stationary. Now out here, if you were to view the KPSS test statistic, you can easily see that 0.355 is greater than 0.21, 0.14 and 0.11. Now since we usually focus on the 5% significance level, I'm going to only focus out here. Now when the KPSS test statistic is greater than these values, which out here at the 5% level is 0.14, we can conclude that this data is non-stationary, and we reject the null hypothesis that the US real GDP is stationary, as the KPSS test statistic is 0.355, which is greater than 0.14, which is at the 5% significance level. This is 0.14. So 0.35 is greater than 0.14. So when this KPSS test is greater than this 5% level significance figure here, data figure, which means that the US real GDP is non-stationary, and we reject the null hypothesis here. Following which, again scroll down, look at the probability values of constant and trend. Again they are less than 0.05, which means that we have chosen the right option of including both the constant and the trend. So now I've shown you these three tests, these three formal tests, and before that there were those two informal tests. So this is basically the way to test whether data is stationary or not. Having said this, economic data, you will see over a period of time, tends to be volatile. It has outliers, structural breaks. So as I had stated before, it's important to conduct in a unit root test. It's very important to conduct breakpoint unit root tests, but this is a topic for a separate video, because dealing with outliers, dealing with volatility in data, structural breaks, this is a more involved a subject, and something which I'll go on later on, but this is just to sort of familiarize you with the point that economic data can be highly volatile. It can have breaks, outliers, abnormalities. So this is just something that you should be aware about. I'll talk about it and how to deal with such data when you actually conduct econometric analysis at the workplace. So for now, I've shown you the way to test whether a time series data is stationary or not. So I'm going to stop here. Have a nice day. Thank you.